Yeah. So, hi, I'm Jordan. I'm a consultant with the Test People, and as was mentioned, I'm going to talk about something called visual automation, in particular using our open source framework that we've developed called Geist. So, during the talk, I'll start with what is visual automation. So, what differs visual automation from your standard sort of automation? Selenium is an example that pretty much, quite a lot of you will have seen. I'm going to talk about examples where you would use visual automation as opposed to something like Selenium. I'm going to talk a little bit about how we do it. So I say how it is done there. There's countless ways you can do this stuff, but I'll talk about our implementation and the challenges we've faced and the ways we've solved those problems. And then I'll talk about a few examples where we've used it, where you could use it, the kind of projects that it's suitable for. So, Test talks about this a little, but what is automation? Where might you use it? How might you use it to your benefit? Good for highly repetitive tasks. So Test talked about the distinction between a check and a test. Automation can't really detect things that it's not looking for. So you're really looking for specific regressions, things to be in a certain place, things to be exactly how you expect them to be. We can use automation at scale. So we can use journeys that we've scripted to load test. We can spin a journey up over thousands and thousands of machines and have it hit the system and work at scale to see how that system behaves at that load. Your approach depends on the type of software that you're going to automate. So Selenium is the example that I used earlier. That's probably one of the most common ones today. That might not always be possible. So using something like Selenium, where you've got a DOM, is really easy, really simple. It's a nice API, but it might not always be possible to use one of these simple APIs to hook into the system and drive it in the same way that a user would. So I just mentioned the word hooks. When I talk about automation, I always think that automation needs a hook. It needs a way to get into the system and a way to drive it to make it behave like a user would interact with it. So every application on the test needs some sort of hook to get into and drive it. So visual automation. So visual automation, our hook is the screen itself. In Selenium, the hook is the DOM. So it's the HTML that's rendered, it's the CSS, it's web elements that you can select, and JavaScript you can inject, and things you can drive in that way. Visual automation is done purely on the screen, and that's about as close to how a user would interact with the system as you can get. So it looks for things on the screen, it finds things, you define ways to find things, and then you interact with the things that you found based on how they look. The simplest and I say simplest, but the most obvious of these is to look for a template, a saved image. So everyone knows what an OK button looks like, or in your system, you might know what your OK button looks like. You can save a version of that. You can go back later and go click on the OK button on the screen, and it goes, great, I can do that. I know what an OK button looks like.
So, give us an example of an OK button or technology where an OK button is displayed, where you would need to use visual automation instead of going back to the old world, QTP or Selenium, for example.
So I'll compare it to Selenium because that's what most people are doing these days, but and I'll cover it a little more later, but something like Flash or Flex, where you don't have the DOM, where you can go in and just say, get me this element, because it's not a web element, it's in some sort of wrapper that's an app or an applet that's running inside a page. It's not the only example.
So the tool itself just can't recognize?
Unless a hook's built in, so unless the developer's built in a way to something like a Flash or a Flex app to say, here's how you interact with the OK button, inject a bit of JavaScript and then play with this thing, there's not always a way to get that thing. But what you've always got in a system generally, if you're going to automate it via the UI, is a screen. So, if there's no other way to hook in, your only option is the screen. So we've got template matching. And then things on the screen have a variety of different properties. So color is an excellent one. If I ask you to click the red thing, it's really easy for you to go, yeah, that's red, I can click the red thing. You've got OCR, so stands for optical character recognition. If I go enter something into the username field, you can read username and go and type in your username into that field. We've got the shape of an object, so the shape and size. Is it a long thing? Is it a tall thing? Is it a square thing? Using its shape, you can say, get me the square thing, get me the long thing, click on that. And we've got the position of something, so get me the topmost thing, get me the bottommost thing. And by combining these, we can define what I call finders, or what we call finders using Geist, to locate objects on the screen and click on them. So get me the leftmost red thing that is next to the username label, or get me the second thing from the right that is blue, something like that. And then by its properties, by its image, we can locate things, click on them, send keys to them, interact with them, just like an API like Selenium. So I mentioned this a little earlier, but if our only hook is the screen, then we need to use something like visual automation to automate based on what it looks like. So a few examples of places where we've used this and where we think it's appropriate is something like a Citrix VDI sort of virtual desktop infrastructure, or VMware, or an RDP session, something like that. You might be testing a system that's on a server somewhere and you can't install anything on that server. You have no access to a DOM or any other sort of hook. All you've got is this virtual desktop that appears on your screen. You've got an image, that's your only hook in. You've got to use this image to find things and click things and interact with things. I mentioned Flash and Flex, so there are ways to automate with Flash and Flex. There are various solutions. If a developer builds in a hook to it, it's really easy for you to use that hook that the developer's built in to go and interact with that thing. But we've certainly seen in the past with clients, the developers maybe somewhere miles away, maybe a third-party developer, you're talking to the client going, can we get this hook available? Can we have a defined protocol that we can use to interact with this thing? And they're like, well, we can try, but the guys are in Latvia and it usually takes 3 months for them to get back to us. So we're like, right, fine, what we'll do is we'll just use the screen because we've got the screen, we can see the system. We'll use that to hook in. And certain applications, so we've got new frameworks coming out all the time like React.js and Angular, things that frequently change the DOM, things that can update things quite quickly, animate. You might find a web element with something like Selenium and then suddenly that's obsolete because the DOM changes so rapidly. So where things change rapidly, again, your only hook might be the screen. So off the shelf libraries, when we came to do this, there were a couple of things, Eggplant and Sakuli. A couple of those have come on a little bit, but at the time, their finders were really naive. A lot of it was the record and playback stuff, which you click on something on the screen, it says, all right, I know what that looks like. It saves a little image of it, but it's very, very brittle. If that image moves, if it changes, if you've got anti-aliasing, so this is a really common problem in visual automation, that font is rendered slightly differently each time with different browsers, different operating systems. The minute differences between little pixels of color just around a letter can be a nightmare for these scripts because the image is completely different the next time you come along. So we found that it didn't give us the freedom using these off-the-shelf tools. So we ended up writing our own open source framework in Python called Geist. So how is it done? So the template matching is the core of it. It's the simplest way to find something. You save an image, you go away, and later on when you see that image on the screen, you know, I found the image, great, I'll click on that. And convolution is the mathematical process in which we template match an image to a screen. So convolution looks a little bit like this. So an image really is just an array of numbers like this. So this might be our screen, our area where we're trying to find something. This here might be the template we're trying to find, just a very simple sort of little dark square maybe, little dark backwards R we might say. And the naive approach would just be to pass this all across the screen and see where it matches. So here we have a 3, we think it matches this region quite well, I think it matches this region quite well. You can see that this matching image is a little smaller than this. That's because it ignores stuff off to the side because you don't really want to match half an image like that. So the mathematical libraries that we use have features to sort of shave that image off the side because you don't really want to match half an image. If you wanted to wrap around the sides, the open source libraries that we use make this available to you, so it's quite easy to tailor this thing to your particular approach. Now, if we were to just get an actual image, do you have a question now? Okay, I thought you were just like that. If we were to do this with just a small PNG image, it's a bunch of pixels, a bunch of colors, and a large screen, it would take ages. It's very, very expensive for you to pass this colored image over an area and try and match this exact picture. So what we do is we use something called, and I'm going to get out of the way of the camera now, so this is going to be really awkward for the guys filming it and use the whiteboard. But we use something called FFTs or fast Fourier transforms. So these are really common in computing. And the example I'm going to use, because it's easier to explain than this, is MP3s. So you might have seen a wave of an MP3 track look a little like that. Something crazy, load of sound, big squiggle, looks a bit crazy. Each of the points here might have some sort of pitch and volume and a set of large numbers that represent the music itself. Now, saving all those numbers individually for every point in that track is quite large. It would take up quite a lot of space, and it'd be quite slow to process it. Yeah, maybe. I mean, this is just a squiggle, but it might get more intense after this. So what we do is we convert this into the frequency space. So to save space, to make it quicker, we basically add up a bunch of sine waves. So you might have a sine wave that looks like that, sine wave that looks like that, sine wave that looks like that, and you can have an approximation of this by adding these together, and it's a much less expensive process. So what we do is do a very, very similar thing with the image, and we convert this into kind of a 3D version of this and pass a kernel over it. The kernel is this here, pass a kernel over the transformed image, and we can do this really quickly. So, sub-second speeds, sub 10th of a second speed to scan across an image and find a sub-image inside that. So that's the convolution, that's the template matching, and that's the core of it. One of the really difficult problems is OCR, and people are trying to find new ways to solve this and better ways to do this all the time. So your first problem is finding text on the screen. Now, there's lots and lots of different ways to do this, but one of the common ways and the ways that we've explored is something called the stroke width algorithm. So text always looks, if I write the word hello here, we can work out where the text is on the screen by looking at the width of the strokes. So we think, oh, hang on, there's a lot of thin lines here of very similar thickness. We can theorize that there's some text here because there's lots of these little strokes that are all about the same size. We think there's a region of text here on this bit of the screen. So we found the text then. The next thing we've got to do is segment it. So you've got a block of text, you don't know what it says. We need to split it into its individual letters so we can classify each one and work out what kind of letter it is. Now, there's a bit of a problem when you come to do this on a computer. So you might think that text just looks like a bunch of pixels. This might be an R here like that. And then next to it you might have an N. There we go. Just really slowly draw out a bunch of squares. Cool. So you might have a couple of letters there, and you might think, oh well, there's going to be some white space, so we'll just split it like that. That's not really ever the case, because we've got this thing anti-aliasing that I talked about earlier. So if you were to zoom out from that text would look jaggedy and hideous and horrible. So computers and operating systems and browsers do a really clever thing where they sort of put a little fuzzy pixel here and a little fuzzy pixel there and a little fuzzy pixel there, and suddenly letters are joined together, and it's really hard to segment this. So what we do is look for something we call a local minima. So here we might see that along this x-axis there's quite a lot of black in this region, there's quite a lot of black in this region where the text is, or whatever colour it might be. And then suddenly where it's just a bit fuzzy, it gets a bit lower. And then we go, right, okay, so what we think there is there's some sort of split between the characters. Now this R and N example is a really difficult one, because more often than not that's recognised as an M. And text segmentation is a really massive problem. If any of you ever crack it, please come and talk to me, because I could really use a really robust solution to how to segment text. So once we've segmented the text, we can train classifiers. So we segment the text in the actual image, but we've trained some classifiers earlier. So what we'll do is we'll take a picture of an R, we'll take a picture of an N, take a picture of various letters, and we'll pass them into a trainer, and we'll take some statistical properties out of it. So we might take the mean value of its colour over the x-axis and the y-axis, and several of the statistical properties, and we'll run them through something like a neural network or some sort of artificial intelligence that will classify these in individual spaces. So go, okay, anything over here is an R, anything over here is an N. So when we pass a new letter through that we've not necessarily seen, something that we found on our screen, it can go, oh, okay, I think that's an R, I think that's an N, and we hopefully get the right letter. It's challenging, it makes mistakes. So like I said, if any of you really crack this, please come and talk to me. And we classify those letters and compare them to the things we've stored, and hopefully we get the right answer, or at least something similar to the right answer that we can think, okay, the thing that says use our name is probably actually username. Cool. I think this is the perfect point to show a video. So I'll show this. So live demos are terrible, so I took a video like a smart person. This is me doing some interactive development with Geist. The text isn't great, but hopefully we'll see some of the images. So I'm using something called IPython, which is an interactive Python interpreter. You write a line of Python, you run a line. This seems to be running really quickly, actually. Maybe I'll pause it. Cool. So, is this pause? Space pause? Cool. So, I have included this today in the open source stuff. So there's something called a prereq file. You can run it in Python, and you can start to play with this today if you wanted. But it provides a series of functions that lets you interact with the screen and capture images and save things interactively. So you don't have to write everything in code. Some things will give you a nice GUI that you can play with. So we have a thing that shows the entire screen. You can zoom into sections using a magnifying glass here. I'll just. So we talked about these the concept of finders earlier. So you have some sort of property that you define. You say, get me the red thing, get me the leftmost square thing, something like that. I have a function here that shows the results of a finder on the screen. So I will define a finder in code. I'll test it out, and this GUI here that I've set up with Python will show me exactly what I've found. So I previously saved an image called upvote. For anyone who's never seen Reddit before, this is Reddit. It has lots of little up and down arrows to vote things that you like and don't like. And I've saved an image of upvote, and it's found multiple of them. So how do I filter that down? So like I said earlier, I can do it based on its position on the screen. I've got something called topmost available in Geist, and there we go. We found just the topmost image. So Geist has highlighted the topmost up arrow based on the previous upvote arrow that I'd saved. So that's a little bit of IPython magic. If you wanted to drill into the code, put in a question mark after something, shows you it. Python's a really nice language if you are not necessarily a programmer, because it's quite scripty. It's quite close to English. There's not a lot of scaffolding, so it makes a great language for scripting tests. I've defined a color here, green, based on its hue, saturation, and value. Sort of an alternative to RGB for anyone who doesn't know. And I've looked for green. I've defined green within some range. And Geist has found this button which used to be green, but it seems to have found multiple things. So that's an artifact of the anti-aliasing that I talked about earlier. So little tiny pixels of green here, there, and everywhere, causing me a massive, massive headache. So I'm going to click the green thing, and it's gone, okay, I'll click this tiny pixel on a letter somewhere down in the corner that you never even expected to be green. So Geist has the ability to show us exactly what it's found in terms of Python objects. These are all the green things it's found on the page, which is thousands of tiny pixels everywhere. So again, I want to use other properties, and I want to define a more complex finder to look for things that to look for the exact thing I want. So I'm filtering it based on its height and width, its shape. I only want things that are bigger than a few pixels, because that is a horrible little artifact of anti-aliasing. So I say, get me the thing with the width greater than 10 here. And I'm sorry for the light of the video that you can't really see, but I'll just have to explain. Get me the thing with the width greater than 10, the height greater than 10. Get me anything that's not a tiny little pixel on the screen. And hopefully this shows it's just found one thing. If we call the other method, it shows that it's only found when I finally highlight this, it's only found the one thing, just this one button. So now we can go and interact with that in the same way you'd interact with something in Selenium. There's click methods available, there's key presses available. You can just go and play with this in the same way. Here's where I need to try and remember what I was doing at the time. It's been a while since I watched this video. So this is me saving an image. So you pop this little screen up. There's a simple method. It's C and 2 brackets pops the screen up in this case. And you just type in a name for this thing, and it saves it to a folder. So here I'm just saving it as Windows Start Menu, and it saves it off to a folder, and that's in that folder as an array of numbers, like I showed earlier in the convolution. And I can go away and find this on any screen later that I want because I've saved it. So that's the simplest and easiest way to find something. Highlight the Windows button and go to find it, and it's highlighted it and found it. Cool. Back to the beginning. Where did I put my slides? There we go. Cool. So I talked about this a little bit earlier, but RDP and Citrix, these things run on another computer. You can't get to them easily. It may be a client, and they say, no, you can't install things on our server, but we still want you to test this. We've got this hook of the screen, and we can still automate. We've definitely used this in the past with the automation at scale approach. So they wanted to test this legacy app and test that people can still use it. You know, hundreds of people can still use it at a time. Great, we can just write one of these journeys and spin it up in the cloud thousands of times and hit the system. And again, legacy applications, the developers might not even be around anymore. You might not be able to go, please, can you build me in a hook? Can you build me in a way to grab into this and drive it in the same way that a human would? So again, we'll just go in and use the screen. So Flash applications, there's no HTML elements in them. Again, if the developer's available, great. Maybe you could build me in a hook. Maybe he doesn't want to. Maybe they're in Latvia, and I say, can I get hold of the developer? No, you can't. So it's excellent for Flash and Flex. I've been using this for the past 2 weeks on a client, just automating their old legacy app before they move to their new HTML5 one, and I've been using Geist to drive the Flash and Flex stuff. Sometimes other things may be more suitable, so if you have got these hooks, great, please use them. The screen can be quite difficult, it can be quite brittle, so things like the anti-aliasing make it quite brittle. UIs change a lot, as I'm sure a lot of you have seen, so you save an image one day, the next release, that image has changed slightly, they've changed the colour palette slightly, and suddenly all your saved images need recapturing.
Can you install object map in the sort of like traditional test automation way?
What do you mean by object map?
So you can identify an object and its properties.
So you could define it based on its properties, but when
it will look for, and then
when its
moves on the screen, it can look for it on the screen.
When its properties change, that's the only problem. So, like I said, you can build a complex finder, get me the blue thing that's the leftmost blue thing with a certain size, and you can define that within a range, so it makes it slightly more robust. The problem is that UIs still do change a lot. The color palette changes, suddenly it's no longer blue. It only takes one of those things to change for you to have to redefine. Yeah. But I mean, with automation, there is always a maintenance overhead. Even with Selenium, if you've got a DOM, someone goes in and adds a whole new set of divs to move things around, and suddenly all you find is your XPaths and your CSS selectors are broken. So as with any automation, there's always going to be an overhead to maintenance, but we suffer it a little bit. And if you've got a protocol available that you can communicate with this system and just send messages to it and automate that way, great. But we don't always have that, so the screen is again our only option. Cool. So I understand that was a little bit technical, and people probably have questions. So if anyone has got anything for me, then please ask.